Can we switch to
Trying
phonics now? I
to
don't
make
want
it
to do
today.
that.
All right, so the test over all this magnetism stuff is going to be on Monday, okay? So we got kind of 2 days to finish up the theory part. You got a lab on Thursday, review Friday, test on Monday. And if there's ever, I know you might not necessarily like a test on Monday, but there's a lot that can go wrong on this test. Like, is it an electron? Okay? Is it, there's an electric field, is it just a magnetic field? So today we're going to look at what happens that you can do to create a magnetic field and a current. So if you look at kind of the history of electromagnetic theory, there's two big ones. One of them is Michael Faraday, and which is why your cell phone, because of Faraday, cell phones tend not to work in this room, because Faraday came up with what was known as like a Faraday's cage. Faraday's cage is basically a metal structure around which no electrical field can interact. And so people have bad cell phone reception inside this room because the walls are made up of, instead of 2x4s, they're made up of pieces of vertical metal. And so that metal is basically acting as a Faraday's cage and preventing the electromagnetic radiation that carries your cell phone signal from coming into the room. So if you have poor reception, it's probably because of the Faraday's cage. So Michael Faraday is kind of an odd story. He actually was not trained as a scientist. He was actually trained as an apprentice bookbinder. But he started hanging out with all these scientists in London. And so one of the cool things about why they think he was able to kind of come up with these new ideas was because he wasn't a trained scientist, so he could look at things differently. So at that point, they knew that if you had an electric current, okay, and here's a wire, okay, so this should be old school, right? So if you have a current going in this direction, so let's assume that you all might have forgotten the right-hand rule over the last 3 days. So if the current's going in that direction, what's the direction of the magnetic field on the top and bottom of that wire? So on the top, are you going to have X's or O's? O's. Okay? You're going to have O's. On the bottom, you're going to have X's. Because you're like this, right? It comes around like this. So you're going to have X's. So, Gap Sean, if I have this current going along like this, and I see a proton, okay, in this direction, what's the proton going to do?
It's going to go towards the wire.
Why?
Because right-hand rule.
Okay? Because the velocity vector is pointing to the right. On the bottom, the magnetic field is going in. So the force is going to be going up. So this is going to make it go up towards the wire. Deacon, what if I shoot a proton on the top side of the wire?
It's going to go towards the wire as well.
Why?
Yeah, it's going to move. The velocity vector is going to the right.
So the proton's going this way.
Magnetic field's going up.
Magnetic field, no, not up.
Out of the page.
Out?
Out of the page.
So the force is going to be going
Down towards the left.
So no matter what, okay, that proton is going to be drawn in towards that wire. If it was an electron, what would happen?
Be
Repelled. So what they figured out is that currents create magnetic fields. So what Faraday tried to figure out is like, okay, he tried to make the door swing the other way. He says, well, if an electric current can create a magnetic field, can a changing, and listen to me very carefully, can a changing magnetic field induce a current.
Sure.
Okay, so he switched the equation, because everybody, all the established physicists going, okay, hey, create a current creates a magnetic field. You can tell it by the deflection on the compass, right? But Faraday stops and he goes, well, that's cool, but if a current created a magnetic field, can changing the magnetic field create a current? And that's what nobody had contemplated before. So, bring out your camera, let's go to the back.